G'day, this is my second attempt at making a video on strictly increasing and decreasing. For some reason the other one didn't work, so if you haven't watched the other one then that's fine, just watch this one. There's a little bit of confusion around this one, just because it's a little bit technical. It's not a big part of the course. In fact, it's probably only really come in the last couple of years, and there hasn't been a lot of exam questions on it. But it is part of the syllabus, so I do need to go through it. It's not overly difficult or complicated, but it can be a little bit tricky sometimes. But I think once you get it, you'll be fine. So when we talk about an increasing graph or a decreasing graph, what we're really talking about is the following y values compared to the previous y values. So for example, in this case, a graph is increasing if the next y value is bigger than the previous y value. Okay, so an increasing graph looks, something like this. This y value here is bigger than this y value here. That's essentially what we're trying to say. A decreasing one obviously would be the other way around, where you've got this y value here is bigger than this y value here. Okay, so now we use this formula, I guess, here to determine if it is actually increasing or in this case increasing. So what we're saying is if B is bigger than A, and like we can make an example, B is 5 and A is 2 or something, just choosing two x values, that's what these are here, the B and A are x values. So given that B is bigger than A, then what we're asking is the y value when x is B bigger than the y value when x is A? If that's the case, then we can assume that this graph is increasing. If I go back to my drawing again, I'll draw it up again. If this is B and this is A, so B and A, and then we say f of B is bigger than f of A. So it's getting a bit squished, but hopefully you can see. So B is bigger than A, and f of B is bigger than f of A. That means that it's an increasing function, okay, between A and B, I guess. And likewise, if f of B is less than f of A, when B is bigger than A, then that means it would be a decreasing function. Okay. The problem arises at a stationary point, and this is why this whole thing has kind of come in, I guess, because by definition, at a stationary point, it's stationary. It's not increasing or decreasing. However, we need to use the stationary point in our calculations of increasing and decreasing. Okay. So maybe if I draw, I'll get rid of this, and if I draw one with a stationary point, like that, I know that it's stationary at that point there. When x is 0, it's stationary. It's not moving up or down. But what I want to do is I want to use this point to work out whether the right hand side is an increasing function or a decreasing function. And so this is where the confusion comes in, because I actually want to use that point. So to get around this idea, and I'll show you an example later on, to get around this, we can say that the function is strictly increasing or decreasing, and that will include the stationary point. Okay, so hopefully it'll all come together when you actually see this here. So I've got y equals x squared as my graph, and I'm asking the question, where is this graph increasing? Okay, well this graph is increasing as in the next y values are bigger than the previous y values from 0 all the way up to infinity, but obviously not including infinity, and not including 0 either, because at 0 it's not actually increasing. Okay, it's stationary at that point. But if I chuck this word strictly increasing in, that means that I have to include the stationary point in there as well. So I include the stationary point, and I can say that it's strictly increasing from 0 all the way up to infinity, but obviously never including infinity. Okay, so this is where, that's basically it. That's the long and the short of it. If it says where is the graph increasing, you don't include any turning points or stationary points. But if it says where is the graph strictly increasing, that's when you would include the turning point that's attached to the area that you're looking at. Okay. Now, hopefully that's made a little bit of sense. If you need some more help with that, please ask me. There is a sheet that I can give you that has lots of questions on this. It's not a big part of the course, but you do need to know a little bit about it. So thanks for watching, and I hope this video works this time. Thanks very much.